Okay, in this video we're going to graph some logarithm functions. So I'm going to start out with a real simple example. We're going to graph the function f of x equals log base 3 of x minus 1. Now remember there's parentheses that go around the x part. The minus 1 is actually outside the logarithm. So when there's nothing inside the logarithm except for the variable x, it's very simple to graph it. So we start out, what I do for logarithms is I take a look at the base. In this example, since we have a base 3, what I do for x is I put the number 3 to the negative 2, and 3 to the negative 1, 3 to the 0, 3 to 1 to the first, and then 3 squared. And 3 to the negative 2 we know is 1/9, and 3 to the negative 1 is 1/3, 3 to the 0 is 1, 3 to the first is 3, and then 3 squared is 9. So that is what goes in the column for x, and then we can simply then evaluate. So if x is 1/9, log base 3 of 1/9 is negative 2 minus 1 gives us a negative 3, and then log base 3 of 1/3 is negative 1 minus 1 is negative 2, and then log base 3 of 1 is 0 is 0 minus 1 is 1, and then log base 3 of 3 is 1 minus 1 is 0. Log base 3 of 9 finally is 2 minus 1 is just 1. And so that makes our table. And so we'll go ahead and plot those. 1/9 negative 3 plots down here, and 1/3 negative 2 plots there, and 1 negative 1 plots right there, and 3 0 that plots there, and then when x is 9, y is 1, it kind of end up off the grid. That's alright, I'll just put it out there. Alright, so that fills in much of our graph. We can see the shape already starting to form. So it looks like that, and you'll notice it looks real similar to our exponential functions. Since logarithms are inverses of their exponential functions, their graphs are going to look similar. That is, they're almost reflections across the line y equals x. Okay. The final thing to do is to find the asymptote. You can kind of see it already. It looks like it runs along the y-axis, that is x equals 0. But the way you can find it algebraically is I always tell my students, look at the exponent, look at what's inside the logarithm, that expression, in this case it's x, and then set that equal to 0 and solve, and that's your vertical asymptote. In this case it's really simple, x equals 0. Okay, so let's look at a more complicated one to graph. So say we have to graph the function f of x equals negative log base 2 of x plus 4. So this one we're going to have to use U-substitution, much like we did for exponential functions. So what we do is we always let u equal whatever is inside the logarithm. In this case that's the expression x plus 4. And so then I'm going to solve that by subtracting 4 from both sides. We get u minus 4 equals x. And so then we'll make our table, and we'll first rewrite our equation in terms of u. We get y equals negative log base 2 of u. Okay, and then let's go ahead and fill in our table. And otherwise the procedure's a lot like what we did in the last problem. The base is 2, so I'm going to take the base to raise the negative 2. Base in this case is 2 raised to the negative 1, base to the 0, the base number to the first, and then the base to the second power. And so if I evaluate those, 2 to the negative 2 is 1/4, 2 to the negative 1 is 1/2, 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4. So that's how I choose the numbers for my column for u. Okay, and then y, we'll go ahead and evaluate. If u is 1/4, log base 2 of 1/4 is negative 2 times the negative 1 is 2. And then log base 2 of 1/2 is negative 1 times negative 1 is 1. Log base 2 of 1 is 0 times negative 1 is still 0. And then log base 2 of 2 is 1. And we have a negative out front, so that gives us negative 1. And then log base 2 of 4 is negative 2. Is positive 2 times negative is just negative 2. Okay, go ahead and find out what x is. So We substitute u into this expression, take 1/4 minus 4, that gives us negative 3.75, and then we will take u is equal to 1/2 minus 4 is negative 3.5, and then 1 minus 4 is negative 3, 2 minus 4 is negative 2, 4 minus 4 is 0. Alright, and then we cross out our middle column for u, we don't need that anymore. And then we'll go ahead and plot x versus y. So negative 3.752 plots about right there. Negative 3.51 plots there. Negative 3.0 goes there. Negative 2, negative 1 goes there. And then 0, 2 goes right there. Alright, so there's our logarithm graph. And then to find the asymptote, you set x plus 4 equal to 0 and solve. You'll get x minus 4 for the asymptote, so we'll put a dotted line in there. There's our vertical asymptote in our graph of f of x equals negative log base 2 of x minus 4. Okay, we'll look at one more example. Let's graph the function f of x equals log base 3 of negative x plus 1 on the inside of the logarithm, and then outside the logarithm of plus 2. So, since we look inside the logarithm, the expression is something other than just x. I'll use U-substitution again. So we set u equal to negative x plus 1. And then if we solve that for u, you could check, solve it for x, you can check we'll get negative u plus 1 equals x. Okay, and so then let's make our table and rewrite in terms of u. Our expression can be written as y equals log base 3, and this we called u, so it's log base 3 of u plus 2. Okay, so then we got 3 to the negative 2, 3 to the negative 1. Again, the base to the 0, base to the first, base to the second. Base in this problem is 3. And so we've got 1/9, 1/3 for 3 to the negative 1, 1, 3, and 9, just like we did in an earlier problem. And then we go and evaluate log base 3 of 1/9 plus 2, that gives us 0. Log base 3 of 1/3 is negative 1 plus 2 gives us 1. And then log base 3 of 1 is 0 plus 2 is 2. Log base 3 of 3 is 1 plus 2 is 3. Log base 3 of 9 is 2 plus 2 gives us 4. Okay, and then if u is 1/9, you take negative 1/9 plus 1, that gives us 8/9. And negative 1/3 plus 1 gives us 2/3. And then we have negative 1 plus 1 gives us 0 for x. And if u is negative 3, then we get negative 3 plus 1, and that gives us negative 2. And finally, if u is 9, then x, as we can check up here, is going to give us 8. Okay, so then we cross out our u column and go and plot when x is 8/9, that's over here, y is 0. When x is 2/3, y is 1. And when x is 0, y is 2. When x is negative 2, y is 3. And when x is negative 8, y is 4. And so there's our graph, and we'll find the asymptote. So to find the asymptote, you set the inside of the logarithm equal to 0. So if you set negative x plus 1 equal to 0, you're going to get x equals 1. So our vertical asymptote in this case is x equals 1, and we'll put in a dotted line there to show that.